One anchor, 600,000 pounds, controlling a 100,000-ton warship.
The USS Gerald R. Ford, a floating city of steel, powered by twin nuclear reactors.
This is the story of the most massive mooring system ever built, tested at full operational tempo. The journey begins not at sea, but here, at a specialized forge, one of the few capable of this work. High-tensile, grade U3 steel, heated to 2,300 degrees Fahrenheit for forging. Quenched in a controlled bath. This rapid cooling creates an incredibly hard, durable crystalline structure.
Every link is ultrasonically tested, inspecting for internal flaws invisible to the human eye.
Proof loaded to 1.5 million pounds, far beyond its intended working load. The central stud is precision welded. It prevents the chain from tangling during deployment. Links are assembled into 90-foot sections. Each one weighs over 360 pounds per link.
Aboard the carrier, sections are joined into a continuous chain, 600 feet long per side.
The heart of the system, the Wildcat Windlass. A 35-ton electric motor provides the power. A multi-stage planetary gearbox multiplies the motor's torque, controlling thousands of pounds with precision.
Stand by to let go the anchor. The mechanical brake is disengaged. The system is now under power control.
The motor engages. The Wildcat turns, feeding the massive chain out through the hawse pipe.
The anchor is released. Gravity takes over, pulling the chain from its housing.
The anchor hits the sea. The ship is still moving at over 10 knots.
The chain runs free. Friction against the steel hawse pipe creates temperatures over 1,000 degrees.
As the anchor approaches the ocean floor, the runaway descent begins to slow. The anchor flukes hit bottom. Their design ensures they dig into the substrate.
The ship's momentum stretches the chain taut. The immense force begins to set the anchor. The anchor drags, its flukes digging deep into the seabed, creating an unbreakable hold.
With the anchor set, the windlass takes control, maintaining the precise tension on the road.
The ship is secure, a testament to maritime engineering, holding fast against wind and tide.
The windlass bears the full load, 30,000 pounds of holding force on a single chain.
Each link is individually marked and tracked. Its entire service history is digitally recorded.
After every deployment, an AI vision system scans each link. It compares surfaces to a digital twin.
Sailors perform acoustic tests. A clean ring means integrity. A dull thud signals a potential flaw.
The windlass is serviced after every major evolution. Bearings are packed with high-pressure grease.
On the bridge, officers monitor the chain's scope and angle, calculating the exact holding power in real time.
Thermal cameras monitor friction points. The hawse pipe can remain hot for hours after anchoring.
To test the set, the ship uses its own power, gently swinging to ensure the anchor is dug in and holding.
The swinging motion buries the flukes deeper. It can plow a 40-foot trench into the ocean floor.
This stability is vital. It enables flight operations from a stationary position anywhere in the world. The order is given to heave around. The process reverses, retrieving 600 feet of chain from the depths. The windlass heaves the anchor. Mud and sediment from the seabed coat the chain. High-pressure seawater cleans the chain as it's retrieved. preventing contaminants from entering the chain locker.
The anchor is secured home. A perfect fit, designed for hydrodynamic efficiency at sea.
The brake is re-engaged and locked. The system is now stowed for sea.
The data is logged. This deployment becomes part of the chain's permanent maintenance record.
From forged steel to ocean floor, this system provides global reach. A silent guardian, holding the line.
Below decks, 600 feet of chain are stowed in a specialized locker, weighing over 100,000 pounds.
An automated system ensures the chain stacks perfectly, preventing dangerous tangles or subtle shifts at sea.
The locker is a confined space. Atmosphere is monitored constantly for sailor safety before any entry.
After each use, the locker undergoes a thorough freshwater washdown, fighting corrosion from the inside out.
Internal inspections use drones, documenting the condition of chains and locker structures without manual entry. A sacrificial zinc coating is applied to critical areas. It corrodes instead of the high-tensile steel chain.
Minor damage is repaired at sea, using certified procedures and materials to maintain full strength.
Non-destructive testing is routine. Magnetic particle inspection reveals the smallest surface-breaking flaws.
Sample links are tested to failure, verifying the ultimate strength of the entire chain's material batch. If a link is compromised, it's replaced, using a certified, proof-tested spare from the ship's inventory. At high speed, the anchor's stowage is aerodynamically clean, designed for minimal drag and noise.
In Arctic operations, ice is the enemy. Steam and manual labor keep the system operational.
Sonar maps the seabed before anchoring, choosing soft mud or clay for the best holding power.
In heavy weather, the hose pipe is sealed, preventing tons of water from flooding the chain locker. A digital encoder tracks every foot of chain, giving the bridge exact scope for critical holding calculations.
Every sailor standing anchor watched trains for months, mastering both normal and emergency procedures.
Emergency drills are constant, training for worst-case scenarios like a runaway chain or motor fire.
In a brake failure, a frangible chain stopper is the last resort. It sacrifices itself to save the system.
Future designs are tested as scale models, optimizing fluke shape for better holding in varied seabeds.
From a dead stop in a calm harbor to securing a city at sea in a storm. In zero visibility, technology takes over. Anchoring by instrument alone required absolute precision.
The anchorage point is selected digitally, accounting for water depth, seabed composition, and swing radius.
Mark the head.
Timing is critical. The anchor must hit the seabed at the precise moment the ship reaches the exact coordinate.
In low visibility, the anchor is walked out. Controlled deployment prevents a tangled, runaway chain.
Friction is managed, not endured. The system operates within safe thermal parameters.
Bottom impact is confirmed by hull sensors, the first critical milestone in the blind anchoring sequence.
The ship pays out scope. 5-to-1 is the minimum. 7-to-1 provides a safety margin in storms.
The windlass heaves to short stay, testing the anchor's initial bite into the seabed. With the anchor set, the dynamic positioning system engages, using thrusters to maintain position and relieve strain. The ship declares its anchored status electronically, creating a digital moat of awareness for collision avoidance.
Anchored and secure, invisible in the fog. A testament to the fusion of brute force engineering and digital precision.
In a storm, the anchor system faces its ultimate test. The chain becomes a massive, dynamic shock absorber. The chain's catenary action is key. Its weight and sag absorb shock loads that would break a straight cable. The brake must hold against surging loads. Its friction surface is engineered for consistent performance under duress.
Below decks, the sound is apocalyptic. The chain groans and shifts under cyclical loads of thousands of pounds.
Anchor watch, report. The anchor is dragging. The watch circle alarm provides the first warning.
The ship uses its own propulsion to relieve strain, easing back to allow the anchor to re-dig into the seabed.
The anchor catches hold again. The system has weathered the storm's peak.
After the storm, a damage assessment begins, inspecting every component, from the flukes to the brake.
Navy divers inspect the anchor itself, ensuring it's not fouled on cables or debris, and that the flukes are intact.
Preventative maintenance is relentless. Corrosion is the constant enemy of all maritime steel.
A fresh coat of specialized paint, the final step in the cycle of use, inspection, and preservation.
Every action is documented. This log becomes the legal and technical record of the ship's time at anchor.
From the forges of industry to the fury of the sea, this system stands ready. An unbroken chain of engineering, procedure, and human skill.
In port, the anchor system stands down. But the mooring evolution presents its own complex engineering challenge.
Millimeter precision is required. Laser alignment ensures the massive hull doesn't contact the fragile pier.
Spare components are global assets. This 30,000-pound spare anchor is shipped from a strategic reserve.
Even the toughest components have a lifespan. Worn or damaged sections are replaced during scheduled maintenance availabilities.
The anchor shackle connection is the system's heart. Its installation is a ritual of precision and brute force.
The entire system is digitally twinned. This model allows for virtual stress testing and maintenance planning.
Supercomputers simulate failure points, predicting stress long before it becomes a crack in the real world.
Training never stops. High-fidelity simulators build experience without risking a billion-dollar warship.
The future is lighter and stronger. Advanced composites and anti-fouling treatments are the next frontier.
Revolutionizing a centuries-old design, using advanced materials science to reimagine the very form of the anchor.
The anchor enables more than stability. It enables life, connecting 5,000 sailors to the shore.
It is more than steel and mechanics. It is a statement of resolve, a guarantee of security, holding... The transcription is forged in fire, tested in storm, and maintained with unwavering...
Even in stowage, the chain is monitored, ensuring complete safety from all potential shipboard hazards.
1,200 foot-pounds of torque. Every bolt securing the windlass is checked to specification annually. The enemy is moisture. Critical electronics are protected with desiccant to prevent micro-corrosion on circuit boards.
Every sensor is calibrated traceable to the National Institute of Standards. Accuracy is non-negotiable.
Tugboats provide a controlled push.
A real-world test of the anchor set without leaving the anchorage.
Some repairs can't wait for dry dock. Certified divers perform underwater welding to maintain integrity.
Robotic cutting ensures perfection. A clean, stress-free cut is essential for a strong subsequent weld.
The system is nothing without the crew. Every evolution, every procedure is built on a foundation of human safety.
The ship marks its own territory, deploying buoys to warn other traffic of the submerged hazard of its anchor chain.
We train for the unthinkable. The procedure to jettison the entire anchor assembly exists, should the ship's survival depend on it.
Data is the lifeblood. Every evolution feeds a shore-based analytics hub for predictive maintenance.
During nuclear refueling, every component is surveyed. The chain is no exception, ensuring it remains radiologically clean.
A legacy of holding fast,
The technology evolves, but the core mission, securing the ship, remains unchanged for over a century.
In the end, it's about trust. The trust of 5,000 souls in the steel, the systems, and the sailors who command them.
Every component begins as a design. Precision engineering ensures seamless interaction between thousands of moving parts.
The primary gears are drop-forged from single steel billets, creating a continuous grain structure for maximum strength.
Computer-controlled machining creates the gear teeth. Accuracy within 5 micrometers ensures smooth, efficient power transfer.
Final inspection verifies perfection. Every dimension must fall within the specified tolerance window. A journey of precision ends. The component begins its voyage to become part of something greater.
The moment of integration, lowering the heart of the Windlass into the still incomplete ship.
Millimeter precision alignment. The gearbox must mate perfectly with the driving motor and the Wildcat above.
Anchored to the ship's structure, the deck itself is reinforced to handle the tremendous forces.
A tradition meets technology. The ship is christened, its anchoring system ready for a lifetime of service.
The journey begins. From raw materials to global guardian, the cycle of engineering excellence continues.
Forged, tested, and trusted. This is the legacy they uphold, ensuring the ship